All right, lexicographical numbers. Guess I must have done this previously, probably on a contest, maybe. All right, given an integer n, return all the numbers in the range 1 to n sorted in lexicographic order. You must write an algorithm that runs of n time of one is of one extra space. Okay. So if you have 13, oh my god, 13 numbers, 1 through 13, in order to be 1, 1, 0, 1, 1, 1, 2, 1, 3, and then 2 through 9. And then if it's just 2, then it's 1, 2. The numbers can be from 1 to 5 to 50,000. Interesting. O of n time. Wonder. So what would you do? So if you have a number n, you can start with all the numbers that start with 1, and then all the numbers that start with 2, and then all the numbers that start with 3. So maybe you can iterate through for each place value, setting the place value to be the minimum for that iteration. How would you do it so that it's so you can't actually just create like a list of numbers and sort it, or list of strings, sort the string, and then convert it back to integers. That would be n log n time to sort. So you have to do it on the fly. Yeah, I don't remember how I did this. I maybe vaguely recall that this was hard, or took me some time. So you go by place value. For each place value that you have. Okay, let's say that n is something random. Let's say 256. So you go with the hundreds being place value 1. Well, you start with actually 1 digit. So start with the place value of 1 at the start. And it could be 1. And then you move on to using 1 as the tens place. At that point, you can use any of and then you move on to using 0 as the ones place. And then you move on and you can use 1, 0, 0. Interesting. So 10, and then instead of doing 11, you would attempt to do 100. You attempt to multiply the number by 10. And because you can't multiply the number by 10 here, you would increment. And you would keep on incrementing. And then you would go back and you would increment here, so it would be 10 to 11, and it'd be 110 through 119, and then you go back and you have 12. Okay, so it looks like if it's possible, then you multiply the number by 10 as the next number. Secondarily, if it's possible, then you would increment by 1. I think that makes sense. So let's say the value starts with 1. I have an answer array. So while the value is less than n, less than n, less than or equal to n, value dot append or answer dot append the value. If the value times 10 is less than equal to n, then you do value equals value times 10. Okay. Else what? Else you would try to increment. But if it's like 119, you would increment to 120. And increment to 120, that's not correct. It would need to be 12. So value plus equals 1. And maybe if that value has a remainder of 10, then it needs to remove its remainder. Yeah, I think it needs to remove all the zeros actually. So for instance, if this was like 199, it needs to go to not 20 or 200, it needs to go to 2, right? So it needs to remove all zeros from the end of the value. So while value mod 10 is equal to 0, whilst we're divisible by 0, then value divided by 10. Maybe this works. No, this can't work. This can't work. I need to check to see that this value. Yeah, this doesn't work. So 13 hits the end, but then I need to go down to 2. So I think if I increment it, I should go down to lower number of digits. But then if the value that I'm appending is, if this value is bigger than n, then I need to go down. If the value is equal to or is greater than n, so for instance, if I go to 14 after I increment, then I need to step down in terms of the number of digits in this thing. It needs to be, needs to do what? It needs to reset down to 1 digit, huh? So it needs to remove the last digit. So it needs to go 13 goes to 14. 14 is above n. And this needs to go down one digit and then increment again. I think it needs to go down one digit. So value divided by equals 10 and increment again. And then if that incrementing has a remainder of 10 or is divisible by 10, then I think I need to remove the 0. I think that might be right. It's going infinite, huh? Okay, so why is this thing going infinite? So it goes 13 to 14. 14 is bigger than 13. So value becomes 1. Then value becomes 2. And then next loop it should go 2, 3, 4, 5, 6, 7, 8, 9. And then it goes 9 to 2, 3, 4, 5, 6, 7, 8, 9. And then it increments to 10. Oof, oofity doofity doof. And then 10 will still go down back to 1. Maybe so 2, 3, 4, 5, 6, 9. Maybe I should use counter for the number of times I do this loop. So what if I did if I in range of n plus 1. Okay, so would that possibly work? So this loop is just hopefully going to always go to the next correct element within the list, and I just need to stop based on the number of elements in the list that I've been doing with the loop. Maybe. I is not the actual value in the thing, so it should be just I from in range of n. Oh my lord. Let's see what other test cases this thing fails. Okay. Interesting. It didn't work for this one, but it might be a little hard for me to tell why it didn't work. But let me think about this. 14,959. Well, so it worked up to some certain number, and then it stopped working. $14,959. Past 24 or 27 test cases. Okay, so let's think about this logically. Why would this not work? I guess I don't fully recognize if this is correct. I think this is pretty correct. If you have a value and you can add a 0 to the value, then you should. So like 1, 10, 100,000, 10,000. That's all correct. And then if you can't add a 0 to the end, then you try to increment. But if you go too far, then go too far, then you need to remove the last digit and add 1. Is that right? Remove the last digit, add 1. And now, while that's a number that's divisible by 10, you remove those zeros, so you have the baseline number. And then the next iteration you can add zeros back onto. Seems pretty right. I mean, it looks like it goes up to a certain value. That's correct of the printout. Okay, let's go ahead and do some smaller test cases. So let's say 14,000. Do I stop working before then? So 14,000 worked. Okay. Let's try 14,500. Okay, 14,900. Now some of these orderings are not actually the same, so it's not necessarily guaranteed that just because it went to, like, it could possibly be that the 15,000 is correct, even though 14,959 is before that. Yeah, so it might be something special with that number. Alright, so let's try 14,958. Oh boy. It worked for one less net, and then stopped working, and then probably worked for one more than it. Something very, very special about 14,959. Oof. Huh. What could it be? Can't even see all the things. Can't even see all the things. I wonder if I can figure out a smaller test case where it stopped working. A simpler test case where it stopped working. What if it was like 59? Maybe it's something wrong with the ending there. Probably 59 works though. It's probably too simple. Oh, okay. There's an extra 1 here. The 6 is in the wrong spot. Or there's no 6 in my thing. Okay, so what happened was 59 went to 60, and then 60 was too big, so it went down to 6, and then immediately went to 7. So skipped over the 6. Why did I? I think I kind of get where I went wrong. So 59 went to 60. 60 was something divisible by 10, so maybe I should be removing the zeros first there. While value mod 10 equals 0, value divided by 10. So 60, I should be removing 0. So it'd be 6. Yeah, I think maybe I need to remove 0 before and after this check. After I increment, I remove zeros, because this is always important to remove zeros. Now, if I didn't, or maybe this could be inside the if statement. No, this would probably be before, because then it wouldn't actually hit this thing if it was, there was no 60, but it was just a 6. I mean, I think this fixes it. I'm not sure if this is the best way to fix it. Having a while loop before and after this statement seems a little awkward. Oh shucks, this is going infinite. You increment it. Okay, so let's go back. Alright, so in a normal situation where I have, let's say, 28, I think 28 works. 29 probably doesn't work, but 28 works. So in a normal situation, I have a value that is some number of digits, like 2 digits, like 19. I add 1 to the value, becomes 20. 20 is not less than 20 is still fine. So 20 becomes 2. And then 2 becomes 20. And then you go through the kind of row of 20s, or row of the row starting with 20. So 21, 22, 23, 24, 25, 26, 27, 28. And then 29. Then 29 is bigger than 28. So I go down to 2. I go down to 2. And then I immediately go up to 3. Because in theory 2 is already done. But if this was something where it incremented and it was like, let's say the n was 29, so it incremented to 30. 30 goes down to 3. 3 hasn't been done. So maybe I can't just append based on the if statement there, because then each loop doesn't guarantee that I add 1 to the value. So I can't just insert an append here, even though that could possibly include the correct number. So maybe I only increment here. So if the number that I have before I do the decrease is divisible by 10, then just decrease it by a factor of 10. Otherwise, decrease it by a factor of 10 and increment it. So if the value itself is divisible by 10 at this point, then maybe I say the value minus equals 1. And then I do this. So I go backwards 1. Maybe that works. Okay. That seems very, very hacky. Very, very special case. The wrong answer. Oh. Well, now. I guess that works. Don't feel great about that. Don't feel great about that. But it satisfies the requirements, even though it logically, this is one where like it's more of a trial and error as a way of solving rather than me fully comprehending all the cases and logically reasoning that my set of my algorithm is going to handle every case correctly. This is more like, yeah, it works in the cases I'm thinking of, and it ends up being that there's no test cases that it doesn't work for, but I don't fully know in my head all the cases, and if there was another test case that it failed on, I wouldn't be surprised in the least, and I'd have to just debug it. In any case, okay, so what do we have here? Summary here is going to be just have a loop that will hopefully iterate through the correct order of values in the array. Use a for loop to guarantee each iteration should add add exactly one element to the answer array. So able to use a for loop that does exactly n iterations to derive answer. And here the key is to have logic that correctly determines from any value what the appropriate following value is within n. So here one idea is any number should be followed by any number x, say x, should be followed by x0 if possible. For example, let's say 10 to 100 if n is like something above 100, like 200. Like you'll see 1, 10, 100. So that's this first part. If the value times 10 is, so you always have the value at the start of the loop, but if the value times 10 is still less than n, then you do that times 10. And then if not possible, deal with logic for incrementing. So obviously the next smallest number would be one more than the current number. And then this is complicated. This is a lot of smaller issues here, but the primary one is so A, remove zeros if possible. So for instance, if you go from 199 increment to 200, this needs to be 2 rather than 200. So say n here was actually 300, right? If you increment 1 in n, you get 200. You need to do 2 before 200. You need to do 2, 20, 200 within the correct thing. So increment, have a while loop that removes the zeros, and then B, if incrementing goes over n, then handle that correctly. And that was not trivial at all. So the correct thing that I found was if while increasing above n you actually reach something that has a 0, then you want to backtrack 1. Otherwise, the general thing that you can do is remove the last digit and increment from 1. So in general, remove last digit and increment by 1, with that one exception, that is if it increments to something that already has a 0, then backtrack 1 before doing that. Alright, time complexity, this can be O of n. As for loop does n iterations, and each loop adds 1 value to the answer array. Now, the value calculation is and the value calculation is constant. Like calculating from one value what the next value is, this is all constant work. There's no n-sized work or value-sized work. And then space complexity, this is going to be O of 1. There's no extra data structures needed. We have a data structure for the answer array, but that's included within the thing.